So, if we look at number 1, this due at page 656. Okay. Number 1 says a population of protozoa develops with a constant relative growth rate of 0.7944 per member per day. On day 0, the population consists of 2 members. Find the population size after 6 days. So when they say the population growth rate is 0.7944, what letter is that? That's your K. Okay. So they gave us that value. And then they also told us that on day 0, the population was 2. So how can we use that information? That's an initial value. So can we like plug that in, or is that a letter that they gave us? That's a C value. C equals 2. Okay, so that's an initial value. Okay, so we're using the formula y equals CE to the KT. They gave us the growth rate. I'm just going to write this down because this could be nice to have since we have the first problem. Growth rate, the way they phrased it, we could tell this was the initial value. Okay. Yes, both, same. Because if you think about it, if you used 0,2 as a point, if you were, this is y of t, right? Y is a function of t. So if you were to plug 2 in for y, and then do CE to the k times 0, then k times 0 would become 0, right? And you'd end up with 2 equals C times 1. So C equals 2. So anytime they give you an initial value, that's really a C value. It's the same thing. Yeah. Okay, good question. All right, so we have y equals CE to the KT. Okay. So now they say find the population size after 6 days. So what are we going to do? Plug in which values? C equals 2. T equals 6. Okay, so we want to solve for y. Y is going to be the population. So 2e to the 0.7944 times 6. So this truly is just a plug and chug problem. It's not even a calculus problem. It's just using that formula, making sure that you recognize when they give you all those numbers what those numbers mean. Okay, so this is going to be a pretty calculator heavy kind of day. And in calculus, how many decimals do we always do? 3, because we want those points. We don't want to lose our AP points just because we didn't do enough decimal places. You don't have to put the 0, that's the only situation, but I don't like exceptions to the rule, so I just always put 3, even if it's a 0, because I just don't mess with it. Yeah. Okay. So you can do regular rounding or you can do truncated rounding. Truncated means you just cover it up, cut it off. Michaela likes truncated rounding. You just like the word? Sounds. I don't know why it's called truncated, but I learned it, and then I felt guilty for all the years that I marked kids down for doing it. I was like, if College Board allows kids to do it on the AP exam, why am I marking kids down for doing it? I was like, you don't know how to round, -1/2. And then the College Board is like, it's okay. If kids want to do that, that's fine. And I was like, dang, I'm a jerk. All right, 234.991. And so we're going to say after 6 days. Because at this point, we always want to be able to answer our questions in context, right? AP does that to us all the time. So after 6 days, there were I'll just say, it says a population of protozoa, and then it says find the population size. So I'd say protozoa. Yeah. Ta-da! It was so fun. Let's do it again. Okay. Number 3. Bacteria culture starts with 500 bacteria and grows at a rate proportional to its size. After 3 hours, there are 8,000 bacteria. Gross. Okay. I always write out the formula. I don't know why. I think it's a compulsion. Okay, so they say we start out with 500, so what are they telling us? C. Okay, and then they say after 3 hours there are 8,000. So what are they giving us? They're giving us a y and a t. So I'm going to say 3, 8,000. They're giving us a point. Okay. So find an expression for the number of bacteria after T hours. So we do have to do a little bit of math for this, because to find an expression, we have to have a K value, because K is not supposed to be a variable. Y and T are supposed to be the variables. Does that make sense? They didn't give us a K value, which means we have to be the ones to find it. Okay, so how are we going to take the given information and find the K value for the problem? Plug in all the numbers. So 8,000 y equals c e to the k t. Okay. And now we solve. Okay, so what should I do first? Divide by 500. So we've got 80 divided by 5. What's 80 divided by 5? 16 equals e to the 3k. Okay, and then what should we do? ln. So ln of 16 equals 3k. And then what should we do? Divide by 3. Okay, so k equals ln of 16 over 3. Okay. Or you could say 1/3 ln 16 if you don't want to write it like a fraction. 1/3 ln 16. Or you could say ln cube root 16. Because anytime you have a coefficient of an ln, we could use property of logs. No? Okay. I'll just leave it like All right, so now we have K. So if we want to answer number or letter A where it says find the expression, how would we now write the expression? Yes, so Y equals 500e to the ln 16 over 3, 2. Okay, so there's our expression. So now we have an equation that is ready for use for the rest of the problem. Okay, part B. Find the number of bacteria after 4 hours. Okay, so now we're going to say y of 4 just can plug 4 in. And what do you guys get? It's decimally. Starts with a 2. Uh-huh. Uh-huh. Perfect. There are about 20,158.737 bacteria after 4 hours. Maybe it's good bacteria. There's good bacteria places. Maybe it's like the bacteria that you want, like from yogurt, that's like good for your gut or something. All it takes is one misstep, and all of a sudden you got worms. Who knows? Who knows? Hi, Reagan. I don't know. Who knows? Who knows? All right. Part C. Find the growth rate after 4 hours, or the rate of growth after 4 hours. So, the rate of change is going to be your dy dt. dy dt. Which is, if we look at our notes, what's dy dt? K, ky. Your dy dt is k times y. So what are we going to do? Yes.
So, Katie, like in our notes, we said that it was relative growth rate, but then also with dy dt is rate of change, aka rate of growth. So which one is growth rate?
So there is y is, it depends on how the questions are phrased. So if you are looking at, hold on. Let me look at how I phrased it in notes.
Proportionality constant, aka relative growth rate, and then for dy dt we said rate of change, aka rate of growth.
Yeah, hold on. Because your k is relative growth rate, proportionality constant. So dy dt is going to be the rate of change of the population over time. dy dt. So if y is the population, then dy dt is the change of the population over time. Does that make sense? Or the change of the population at a specific time. So when they say in part C, find the rate of growth after 4 hours, they're asking at a specific time, which is why it's not just K. They're asking at 4 hours. Now, when they say you have a growth rate of something per day, now they're talking about how something grows in general. Do you see the difference? Okay, so that's how you can kind of tell them apart, is like how something grows just because that's what it is and that's how it grows. That's your proportionality constant. They're talking about a constant. That's how that grows. Versus this is how the population is changing at this moment in time. So we talk about, like, if we're gonna talk about the like proportionality constant of like people are going to reproduce, like a individual person can only reproduce at a certain rate, right? Because women are pregnant for 9 months. So a woman could not produce 100 children a year. That's insane, right? So there's a limitation to how many children a woman could produce a year. But then you can talk about the population of how fast people could populate the earth. So if we were to go back to, like, whether or not you believe in the Bible, if we were to go back and talk about Adam and Eve, how fast the population of the world was increasing at that time, that dy dt would be significantly smaller because the population of the world at that time was very small, as opposed to right now, the population of the world, how fast that is increasing because there are 6 billion people populating right now. Does that make sense, the difference? Whereas that K is kind of like how fast an individual woman could be populating. See the difference between those two things? Okay. So I think that's, if you start to think of it that way, as the K is that proportionality constant, that growth rate that thing has, as opposed to now you've got a population where you have, that's why it's a K times a Y, because it's the population being multiplied by the K. So it's how fast that individual, that type of thing can grow, multiplied by how big that population is. Make sense? Okay. Sorry, I just had to go back and look at the wording. Okay, so taking the population for part C, we are looking at 4 hours. So we're going to take our constant, our proportionality constant of the growth rate, and we're going to multiply it by how big the population was at the 4 hours. Now, we cannot use a rounded number in the middle of a problem, and we are in the middle of a problem here. So we can't use this rounded number even though it's just barely rounded. We have to go back and use that decimal in our calculator that was 4 digits, not 3. Okay? So we're going to take that, and what are we going to multiply it by? Not 500, that's C. What's our K? 1/3 ln 16. So make sure you multiply it by, now we've been doing a good job with this K value because this K value was easy to write down, but if you ever have a K value that was like funky to write down, so you had been writing the decimal the whole time, then you would want to make sure that if you had a K value that was like that, that you stored your K value in your calculator so that you could have that perfect decimal that you're plugging in and not a rounded number. Does anyone need a reminder on how we store values in our calculator? Yes? Okay. So if you wanted to store a number, let's say we wanted to take this and we wanted to store it, I could do that right now just by, if you have this as the last thing in your calculator, you could hit the STO button. And I'll go ahead and store it as Y, since Y represents the population. Where's the Y? It's number 1. So Y is green. So now I'm going to hit alpha 1. So what it's going to do is it's going to say I'm taking my previous answer and I'm storing it as Y. So now anytime I hit alpha 1, anytime I hit Y, it's going to use that stored number. Does that make sense? Okay. So now I could also type ln 16 divided by 3. I'll go ahead and take that decimal point 924. I'll store that as K. And now I could go ahead, and we didn't really need to do that for this problem, but it's good practice. Now I can do that K times Y. K times Y, and see what that answer would be. Does that make sense? Okay, so I'm just going to write down on my paper what I did. I had ln 16 divided by 3 times 20,158.737. And when I multiplied those together, I got that the relative growth rate at that point in time was 18,630.629. And what would the units be if we're thinking about this is the growth rate at this moment in time? What would our units be? Bacteria per hour or cells per hour. How did they phrase it? Bacteria? Is it bacteria per hour? Bacteria per hour? Okay. Okay. All right, part D. When will the population reach 30,000 bacteria? So, are we using dy dt still, or are we just using y? We're just using y. Okay, so we're going to say y equals, we're using the formula y equals 500 e to the ln 16 over 3t. And then where are we plugging in the 30,000? We're plugging it in for y. Okay, what should we do? So for t. What do we do next? Now what should we do? Actually, I'm going to leave the 3 on the bottom. Okay, now what should we do? Let's play the 3. Yeah. Yes, you can. The LNs.
Like the LM 60 would be common number, would be common constant. That's why
You don't. This is the change of base formula. So ln 60 over ln 16 you could rewrite as, hold on, I have to think. I have to not brain fart right now. You could think of this as log base, what is it? this is the same as, I think it's the same as log base 16 of 60, I believe. It's the change of base formula. We can just type it in and see what the decimal is. At this point, you can just type it. You can't cancel them out though because it's an operation, so you can't, if you had a plus over a plus in a fraction, you can't cancel out your pluses. So you can't cancel them out. But if we're talking about simplifying, I'm pretty sure that this is that. But let me put the 3 in the front. Yeah, Miss Rice, remembering her log stuff. It's the change of base formula. So if you wanted to simplify it and only have one log, you could rewrite it as log base 16 of 60. I wouldn't do that, but if you wanted to, you could. Man, I'm impressed by myself. Go, Miss Rice, go, Miss Rice, go, Miss Rice. All right, so it's 4.430. What are the units? Hours. Okay. There will be 30,000 population. There will be 30,000 bacteria in 4.430 hours. Okay, do not be worried. Not all the problems had this many parts. Only problem 3 did. 1, 3, 7 through 19. 7 has 2 parts. 9 has parts. And then after that, 11, some of them have parts. There's not that many problems. Okay. Go ahead and keep working. If you guys are okay, are we ready to kind of work on our own? We feel more comfortable now? Okay. Go ahead and start working. This part. Okay, so if you look at 7, just because 7 looks kind of weird. Zoomy. So, do you see how this kind of looks like dy dt? dy dt. See that? dy dt. So this is kind of like a ky. dy dt ky. But dy dt is not supposed to have a negative with it, right? So what I did is I moved the negative to the other side. So I thought of this as like a y. dy dt, this is ky, except this negative needs to move over here. So if that is the case, then what's your k value? You're close, because you took the negative and you moved it over. Negative 0.0005. And in part A, you do not have enough information to actually solve for C, because they did not give you an initial value. So this is kind of like having that dy dt equals ky. You only have enough information in part A to have the k value. You don't have an initial value, you don't have C yet. So when you start off writing your equation for part A, you can only plug something in for the k value. You can't plug anything in for C yet. It says the chemical reaction takes place at 45 degrees. We are not chemists. It doesn't say anything. I don't know enough to know if that's an initial value or not. I am not a chemist. I'm at a chemistry. So.
No, but it says initial concentration is not temperature.
Yeah, so I just put a C in there. I literally just let C be C. Yeah. Now, when it says you're reducing your concentration to 90% of the original value, I called my original value 1 because they didn't tell you how much of the how much you had of something. So anytime they don't tell you how much of something you have, you can make it be whatever. So I called the original thing 1. So I said my like initial value was like just 1. Does that make sense? And so then after that, I could say that my next value would just be 90% of that. Does that make sense? So my first, so for part A, I have negative dy dt equals ky, except where the y's are, they are putting N2O5. So that's what the y's are in this problem, is the N2O5. So dy dt equals negative ky. And so the y is the N2O5. The k is the 0.0005. So when I have y equals ce to the kt, I'm going to have N2O5 equals ce to the negative 0.005 t. I missed a 0. Based on how they wrote it. This is how their variables are. Does that make sense? Okay. So that's part A because I got nothing else. Okay. Now, for part B, I can have my initial value. You could do something like you could say your C value is 1 when you're, and then when you have your 90%, that could be 0.9. Does that make sense? Or you could do C is 100 and then do 90. Does that make sense? Or you could do C is 10 and then do 9. See how I'm kind of writing like different pairs? So this is where we're doing like 100% of something as my initial value and then 90% as my next value. Yeah, does that make sense? So that's where I'm kind of getting at that idea of I don't know what I'm starting with, but I know I started with 100% and I know my next value is 90%. Okay. I'm plugging the 90 in for the y value. Okay. All right, which one do you guys want to use? The first one?
Yeah.
Okay, so we'll use the first one. Okay, so if we use that first one, we're going to say y equals, or the N2O5 equals, 0.9 equals E, CE to the K, T, because we didn't know when it was 90%, we just know that the next value was that it was 90%. They didn't say when. Does that make sense? Okay, because the question says how long will it take to become 90%? Okay, you guys good? Can you finish that part of the problem? Okay. Yeah, that one was worded weird. We probably should have started that one too. Okay, looking at the answer key after that, there's another question like this, but it's, I think now that we've done this one, 11 is the next one that looks like it's like this, but I think you'll be more comfortable.
That's what I got too. I got negative 4,000.
Okay, I'm adjusting your assignment to make up for the fact that we are not doing those notes, okay? So here's what you're gonna do. You're doing 1, 3, you're gonna do 7, 9, 11. This is on Stewart. 7, 9, 11. You can't do 13 or 15 because you won't know how to do them. And 17. So these are the ones you're going to do off the Stewart assignment, okay? I'm going to hand out the worksheet because you can do a couple of those. And then you're going to do, from the worksheet, you're going to do 1 through 3, okay? And then tomorrow, we're going to do the other notes, and then you'll be able to finish up the other couple problems. So you're going to do about the same number of problems as you would have done today. We're going to be skipping around a little bit. Okay? All right.